Which of the following molecules has a square planar molecular geometry? A. Methane, CH4. B. Water. C. Sulfur, tetrafluoride. D. Xenon, tetrafluoride. Valence shell electron pair repulsion, or VSEPR, is a theory that explains the geometry of molecules. The theory states that because like charges repel one another, electron groups want to be as far apart as possible and will arrange themselves around the central atom in a manner that maximizes distance between electron groups. Also, electron groups with higher electron density require more space, meaning that lone pairs take up the most space, followed by triple bonds, then double bonds, and finally single bonds. VSEPR is the reason that molecules with 4 electron groups are not planar, with bond angles of 90 degrees, but are actually three-dimensional, with bond angles of 109.5 degrees. We represent 3 dimensions in drawings with wedges for bonds coming out of the plane of the paper and dashed lines for bonds going into the plane of the paper. Square planar molecular geometry results when the central atom A has 6 electron groups surrounding it, 4 atoms X and 2 lone pairs, E, and has the general formula AX4E2. More than 4 electron groups means that the atom must be in the 3rd row or lower of the periodic table in order to possess this expanded octet. When we look at the answer choices, we see that we can eliminate choices A and B, as these central atoms are in the 2nd row of the periodic table and cannot have expanded octets. We must draw the Lewis structures for sulfur tetrafluoride and xenon tetrafluoride to determine which has a square planar geometry. We'll start with sulfur tetrafluoride. We find sulfur and fluorine in the periodic table and see that we have 34 electrons in the molecule sulfur tetrafluoride. We place the sulfur atom in the center, attach fluorine atoms with single bonds, and complete the octet around each fluorine molecule with lone pairs. When we count the number of used electrons in the preliminary structure, we get 32 electrons. 2 electrons too few. To remedy this, we place the extra 2 electrons around on the sulfur atom as a lone pair. When we recount, we see that we have now used the correct number of electrons. Next, we'll draw the structure of xenon tetrafluoride. We find xenon and fluorine in the periodic table and see that we have 36 electrons in the molecule xenon tetrafluoride. We place the xenon atom in the center, attach fluorine atoms with single bonds, and complete the octet around each fluorine molecule with lone pairs. When we count the number of used electrons in the preliminary structure, we get 32 electrons. 4 electrons too few. To remedy this, we place the extra 2 electrons on the sulfur atom as a lone pair. When we recount, we see that we now have used the correct number of electrons. Now we count electron groups around both center atoms to determine which will have a square planar geometry. We see that xenon is the central atom with 6 electron groups, 4 atoms, and 2 lone pairs. Therefore, the correct answer is D.